So now we're going to consider how to show that the binomial distribution is a member of the exponential family of distributions. So we start with stating our binomial distribution. So that's f of x equals n choose x, p to the x, 1 minus p to the n minus x. Step 1 is take the log of both sides. So you need to remember that although this can seem to be quite a simple procedure, you want to remember that it's to your advantage to do this the same way every single time. So taking the log of both sides, we get log of f of x equals log of n choose x, that's a bit horrible, we're hoping not to have to deal with that, plus x log of p plus n minus x log of 1 minus p. Then we take the exponential of both sides, so that's step 2. So that's f of x now equals to the exponential of all that was up here. You can start thinking about reordering things slightly and grouping together your terms that contain your data and your parameter. So that's x times log of p minus log of 1 minus p. Then your terms just containing your parameter, which is just containing p, n is fixed variable, so that's plus n times log of 1 minus p, and then containing your data and any fixed constants that aren't linked to your parameter, plus log of n choose x. A little bit more rearranging to make it look slightly nicer is exponential of x log of p divided by 1 minus p plus n log of 1 minus p plus log of n choose x. So now we want to think about what form we would like this to be in. So we compare it to f of y. I'm deliberately using a different variable name here as opposed to x, equals exponential of theta y minus b of theta divided by a of phi. For a single parameter distribution, remember that this is going to be a constant, plus c of y phi. So now we have to remember to think about how we're going to match things up. Immediately we can see that we should let theta equals log of p divided by 1 minus p. If we do that, we then want to be able to express log of 1 minus p in terms of theta to get our b of theta function. So we have e of theta equals p divided by 1 minus p, and hence, with a little algebra, do try to practice this yourself, p is equal to e to the theta divided by 1 plus e to the theta. So 1 minus p is equal to 1 plus e to the theta minus e to the theta over 1 plus e to the theta. So that's equal to 1 over 1 plus e to the theta. Which is equivalent to 1 plus e to the theta to the power of minus 1. This will become obvious why I'm doing it in this form when I say n log 1 minus p is equivalent to then n times log of 1 plus e to the theta to the minus 1 is equivalent to minus n log of 1 plus e to the theta. So I now can say f of x is equal to the exponential of x theta minus n log 1 plus e to the theta plus log n choose x. Matching this up to what's in black up here, I can then say that b of theta is equal to n log 1 plus e to the theta. And everything else pops out. And so a of phi is equal to 1, and c of x and phi is log n choose x. That is shown that the binomial distribution is a member of the exponential family of distributions. I'll then proceed to demonstrate that I can find the mean, the variance, and the canonical link of the binomial distribution.